All right, let's take a journey. We're going to a place that's more alien and, frankly, more hostile to us than the cold vacuum of space. We're heading down, way down, deep into the ocean to figure out what happens to a human body in the abyss. You'll see the rules we live by up here, they just don't apply down there. And that's not just some poetic exaggeration. That's the real deal. See, right now, we're all sitting under what's called 1 atmosphere of pressure. But for every 33 feet you go down into the ocean, you add another entire atmosphere of pressure. Go deep enough and that force becomes, well, it becomes something our bodies just can't handle. So our first stop on this trip down is to get a handle on the main force we're dealing with, hydrostatic pressure. It's pretty simple, really. It's just the massive, inescapable weight of all that water above you, squeezing you from every single direction all at once. To make a number like 16,000 pounds per square inch feel real, just picture an elephant standing on your thumb. Now imagine that same force on every single inch of your body. That's what we're talking about at the deepest point on this planet. So you have to ask, what on earth happens when that kind of force meets a human body? It's the image we all have in our heads, right? Like something out of a cartoon, just pancaked flat. But the truth is actually way more specific and, in a lot of ways, much more fascinating. The short answer is no, it doesn't squash you flat. But the reason why is what reveals our first major vulnerability. So here's the key thing to understand. Our bodies, our organs, our blood, our tissues are mostly made of water. And you can't really compress water, right? So the pressure from the outside just passes through us, evening out almost instantly. The real, and I mean real problem, is the empty spaces, the pockets of air we carry around inside of us. And that brings us to the first catastrophic thing that happens on our descent, the violent compression of every bit of air inside you. This is where the body starts to fail spectacularly. This is all because of a simple, kind of brutal law of physics that there's just no getting around. As the pressure outside you doubles, the air inside you gets squeezed to half its original size. Double the pressure again, it halves again. And in the ocean, this isn't a slow motion thing. It's a rapid, relentless collapse. What you get is this devastating chain reaction. The air in your sinuses, in your middle ear, even in your stomach, it all gets compressed violently. Your eardrums, they'd rupture in a heartbeat. But the most dramatic failure happens right in your chest. Just think about that for a second. The sheer force of the water pushes your ribcage inward, crushing your chest, until your lungs, which are basically just bags of air, are compressed into something no bigger than a coin. The failure isn't gradual, it's immediate and absolute. Okay, but let's just imagine for a second that you could somehow survive that physical crush. Let's say you're in some futuristic suit. Even if you could beat the physics, there's a much sneakier danger waiting for you. Your own body chemistry starts to work against you. This is something deep-sea divers call the raptures of the deep. You see, under extreme pressure, the nitrogen that's in the air we breathe starts to act weird. It actually dissolves into our blood and our fatty tissues, including our brain. And it starts to act like a powerful anesthetic, completely twisting your perception of reality. Honestly, the best way to wrap your head around nitrogen narcosis is to think about being drunk. Seriously. But the stakes are infinitely higher. A diver might feel a sudden wave of euphoria, their judgment gets completely shot, and they might do something fatal, like just casually taking their own breathing regulator out of their mouth. So, let's get back to our unprotected descent. We've talked about the physical squeeze and the chemical betrayal. But what happens at the very bottom, in places like the Mariana Trench, where the change from 1 atmosphere of pressure to over 1,000 happens in an instant? Well, this is the final moment. The answer is it's not a slow process. It's not even really a process at all. It is an event of such unbelievable violence that the whole thing is over and done in less than 1 second. It's not a collapse, it's an obliteration. In that final moment, there's no sequence. It's all at once. The lungs don't just collapse. For all intents and purposes, they vanish as water rushes in. The ribcage shatters inward. The pressure difference is so great that the skull implodes, and it can even force the eyeballs back into the skull itself. It is completely over before a nerve impulse for pain could even think about reaching the brain. And if you need a final image to understand the sheer violence of this, think about this quote. The energy from the water rushing in to fill the space where your lungs used to be
is about the same as the energy of a rifle bullet. This is not a gentle squeeze, it's a violent, energetic implosion.
So, as we come back up to the surface from this little thought experiment, we're kind of left with this amazing contradiction, a paradox about our own bodies and our place on this planet. And that, right there, is the big takeaway. We are water-based creatures. We literally came from the ocean. And yet, the extreme physics of the deep sea, a part of our very own world, make it a place our bodies just can't exist. It really makes you wonder, in all the unexplored parts of our own planet, what other fundamental rules of nature are we just completely unprepared for?